Great. Yeah, then a warm welcome to everyone. I think we have a really global audience today, so good afternoon, good morning, good evening, depending where you are joining us from. It's my pleasure to welcome you to this webinar today. Our topic is innovation in cooling. My name is Christine Jonen, and I am working in communications at GIZ Proklima. And today I have the pleasure of being your facilitator and guiding you through this webinar. The session were planned and prepared in cooperation with two of our partners from the Green Cooling Network. They are called Pervormance and MAGNOTHERM. These are two pioneering German companies that are redefining cooling from new perspectives. So I'm really happy to have Sabine Stein from Pervormance International with us today and Timur Sirman from MAGNOTHERM. And of course, last but not least, Michel from GIZ Proklima for the welcome remarks. Great to have you with us today. So before we begin, let me share some important technical details. I'm sure you all know this from other webinars. The webinar is being recorded so that we can publish it on our website afterwards. You find also all the other recordings from the different webinars from the last years in our section videos and publications. The chat will not be included in the recording, so feel free to raise all your questions in there. Please keep your microphone muted during the sessions, and if you have any questions, feel free to type them in the chat. We will have a Q&A session after the two presentations where we can address all your questions, or depending on the time, at least some of them. I'm joined by my colleague Magnus Mangold today. He will assist with technical issues. So if you need help or have other individual questions, you can reach out to him in the chat and we will try to help you. I would say let's test the chat to start with to make sure that everything is working. I have a question for you. How is your mood today? How are you feeling? I would like to see some emojis in the chat. So just select something that corresponds to your mood today and we can see where we are. I see smiling faces and hearts. That's great. Sunglasses, also nice. Here it's raining in Frankfurt today, so it's nice to see that. Perfect. Yeah, perfect. I think, yeah, or I'm glad to see that we are in a good mood today, and I'm think also excited about the session, I'm sure. Yeah, so let's take a look at today's agenda. First, we will begin with opening remarks from Michel, project manager at GIZ Proklima. After that, Timur Sirman from MAGNOTHERM will introduce us to a safe, sustainable, and efficient magnetic cooling technology for commercial refrigeration and beyond. And afterwards, Sabine Stein from Pervormance International will tell us more about active cooling textiles. And as I said before, we will have then the Q&A session where we will address, where you can address any questions. So let me now give the floor to Michel, and she will kick off the webinar with some opening remarks. Over to you, Ellen.
Thank you, Christine, and a warm welcome to all the participants. I'm glad so many of you could make it today. And obviously the topic raised your interest, and even warmer welcome to Timur and to Sabine for being our speakers today and for agreeing to share your experiences and your innovative cooling technologies with us. Both companies are members of the Green Cooling Network, which we are very happy and proud about. Proklima, as I think most of the participants know, is the cooling cluster that is implemented by GIZ. We are running different projects, all with the objective of promoting green cooling. And the overall goal we're aiming for is the transformation of the cooling sector for the benefit of the people, the environment, and our shared future. And usually we're promoting natural refrigerant gases. But today we're very happy to see there's also cooling without gases, which might be actually even better for the environment, for the climate. There's no need for continuous electricity consumption, which of course is also one of the main drawbacks of the cooling. And therefore, I would just like to invite all of you to listen carefully, to share your comments, questions after the presentations of the two speakers. And at the same time, also let me invite all of you who are not yet to the Green Cooling Network. This network is open for anyone who also wants to work towards the goal I just mentioned, towards transforming the cooling sector. And the members have the chance to actively contribute, to exchange in network meetings, webinars, such as the one we're having today, and to also use the resources we are preparing. And we are also welcoming very much if any of you have topics to share, or if there's something that you would like to learn more about. We're happy to pick it up if you contact us, and then we could organize a future webinar as the one we're having today. And with that, back to you, Christine. Thank you.
Thank you very much, Ellen. And now I would say let's go over to the first presentation. I'm really pleased, as I said before, to welcome you, Timur. Timur Sirman is CEO and co-founder of MAGNOTHERM. He's an engineer himself and has been working with the magnetic technology for over 8 years now. That's what you told me. So really impressive. And let me remind you, if you have any questions during the presentation, please post them in the chat and we can discuss this afterwards. So Timur, the floor is yours.
Yeah, thank you very much, Christine. Thank you very much for Ellen for the very welcoming introductory words. I'm super excited actually to be here today. Already said it in the previous discussion before we had the webinar. I think this mission that you are on, it's extremely important, and it very much aligns also with our company vision that we want to shift the cooling industry towards better alternatives. And in our perspective, magnetic cooling as a refrigerant-free cooling technology is a better alternative than to current systems. So today I would like to use this opportunity to introduce our magnetic cooling technology as a safe, sustainable, but also as an energy efficient alternative for commercial refrigeration, which is our first market entry, but also beyond commercial refrigeration. So with this, thanks for my personal introduction. I want to briefly also introduce our company. So we claim to be the pioneers of magnetic cooling. Magnetic cooling as a technology is not new. So there's a history to the technology that goes way beyond our company history. But we position our company as the people who can actually do it now. So we do that because we derive from materials research. So I'm very confident to say that the research group at Technical University Darmstadt here in Germany is one of the world leading research groups in this particular field of magnetocalorics. And just the other day, there was actually a groundbreaking scientific discovery on this technology, also from the research group that derived together with a Japanese research group. And this underscores the background that we have. And what we did in the past is actually evolve as a materials company into an engineering company. So we have developed prototypes, machines, and with this also a lot of intellectual property that puts us now into the position to commercialize this technology and to make it widely available to different industry segments. Yeah, we are a startup company. We are funded by investors and by public grants, and always happy to discuss potential investment opportunities if we have people in the audience here as well. So I don't think to this audience I have to say a lot where we stand with cooling and what the global impact is. We are in this vicious cycle. Global warming means more cooling, and if we rely on the old chemical-based refrigerants, we are getting nowhere. So we need to change something. I think this motivation is quite clear to all of us. I think it's always interesting also to reiterate on the fact that cooling is just a very tremendous part of the modern society that we have, and it's a critical bottleneck for various parts of society. Of course, food and beverage, we need to refrigerate our food. We want cold drinks, but also for manufacturing, we need temperature-controlled machines. And the internet, what we're doing right here, wouldn't work without temperature-controlled chips. So it's basically the hidden enabler for a modern society. And also we want to live in a temperature-controlled environment in order to be productive at work, but also to feel good and not to be too stressed by heat or also on the cold side. The problem that we all see is that 95%, just take this with a grain of salt, it's not a well-researched number, but it's in the ballpark, is still running on F-gas refrigerants. And we need to go away from them. So natural refrigerants is the way to go to bring down the global warming potential from refrigerant-based systems. And we have clear milestones here in Europe with the F-gas regulation and also with the Kigali Amendment to the Montreal Protocol globally. This will be rolled out, and this is the way to go. When I started the company, there was this book on how to mitigate carbon emissions, and the #1 mitigation strategy to bring down the refrigerants that we're currently using. And this is why, again, I think it's extremely important to follow through with this regulation globally. Of course, we need to make sure that the systems run safely. So regulation compliance is one thing, but also we need to have good systems that are easy to maintain and which are not harmful to operators or to maintenance personnel. So what you see here is basically a list of different refrigerant gases and how they compare in terms of the global warming potential, but also in terms of safety. And we see that magnetic cooling can contribute as a technology that has a zero global warming potential, but also that complies with maintenance-oriented certifications, such as the European norm DIN EN 378, and at the same time having a system that cannot explode, it cannot ignite, it has no toxic materials in there, and it also does not release any PFAS or such as any other chemicals. So forget refrigerants. We don't need them. That's the claim that we are making. We use instead those magnetocaloric materials that you see here. So we have a system that completely eliminates the need for gases and replaces it with a solid state refrigerant, if you want so. But yeah, the working principle is basically that those materials, they heat up and cool down with magnetic fields. So similar to a gas compression cycle, we also follow a 4-step cyclic process where we magnetize this metal block with an external field. So we have a magnetic field that goes to the metal block, and then this metal block gets hot. And this heat can be extracted with a coolant. So we have a water-based coolant that extracts the heat from this metal block. And this way we also have a heat pump. So we create hot water, but in a cooling system we reject it, similar to a normal gas compression-based system. And in this magnetized state, but we have reduced the temperature by exchanging the heat with the fluid, we can demagnetize the material now, and this effect flips around. So at the end of the day, we have a cold metal block because we demagnetize the material, and this way we can then reversibly cool down water. And this makes it inherently beneficial. And there's a long list of benefits that can be derived from that. But before I dive into it, I want to illustrate it again in this video. So we have a magnet that magnetizes here this block of material. The whole material heats up, and then we extract the heat, and this way we can build up a temperature gradient throughout the material. And this is all when it's magnetized, and by demagnetization, this whole temperature gradient drops, and we can push water through the other direction and basically capture cold water from this metal. So it's a cyclic process. The big difference to gas compression is that heat and cold is generated in the same location. And we are doing this twice per second. So it's a continuous process. It's not as time discrete as you would imagine from this video, but it's a continuous process where we are cycling this material twice per second. In this way, we can generate significant cooling power. So what does this mean? No refrigerant means inherently safe. So we have those magnetically activated materials and water as a coolant for the cold distribution. And again, nothing can explode, nothing is flammable or toxic. But it's also very sustainable. Zero global warming potential, no F-gases, no PFAS. We design our systems in a way that you can disassemble all the components to make them reusable, which is beneficial from an environmental perspective, but also from a cost perspective. So you see this trend which comes to industry more and more, that robots are used to automatically disassemble components. And I've just recently this week learned about, I think it was LG, designing a heat exchanger which is optimized for disassembly rather than optimized for performance alone. And we are following the same principle here. So we design from the ground up our machines in a cradle-to-cradle principle. What is, I think, very relevant is that we can also retain the efficiency, and we can even increase the efficiency of cooling systems. So we have a system that uses magnetic forces in order to generate this effect. And similar to a motor or an electric vehicle, we can recuperate the forces and the energy from the forces. So we basically have a balanced system that magnetizes and demagnetizes, and those forces involved result in a higher efficiency because we can recuperate on the cold part of the cycle, which you normally would not have in a gas compression system where you expand the refrigerant gas. And with this expansion, the energy basically is lost. But also inherently, from a fundamental physics perspective, the efficiency can be, theoretically speaking, 100% higher. So we, as a German conservative company, we make the claim that we can increase the efficiency by 30%. But this is, again, it's a conservative estimation. What we see in actual results, so this is from the commercial cooling sector, where we have run a one-to-one plug power comparison with a propane-based cooling unit, a cabinet that is a top loader configuration, which you would normally find in supermarket layouts. And there, the retailer, which will be announced in the coming days, who it actually is, but it's a large German retailer. They have validated a 15% energy efficiency increase compared to the best-in-class systems that they're currently using. So we are already along the way to higher efficiencies, up to 30%, but yeah, it's not going to take us long to make this. And yeah, I think the most interesting part for operators is it's very low maintenance. So we run at atmospheric pressure with our system. So 1 bar, even sometimes below 1 bar, and we are using water. No oils involved. We don't need certified professionals for servicing. So an electrician is already able to work with our system, and we can build it in a cassette style cooling unit way, so we can easily disassemble or detach our cooling unit from the actual cooling system, because you need to basically unplug the water connections, and then you can replace it quite easily. So those are very large potentials and opportunities for the operators, and this is where we see a lot of interest coming from this perspective. So our platform, as we call it, is Eclipse. It's around 1 kilowatts of cooling capacity, so rather small. But in the context of commercial cooling, it's quite interesting because we can run different types of cooling cabinets. But of course, you can also bring it to other industry segments, such as small scale machine cooling or IT cooling. And you can use it as a standalone chiller or directly integrated. And there we have integrated it into different cooling cabinets. I've seen here colleagues from the company EPTA also in the call. So your recent acquire as of today, Hauser is one of our partners, where we will also show one of their standard units with our magnetically cooled chiller system. So here on the left, you can see basically our demo device. It's a beverage cooler that we started out with in supermarkets to show that magnetic cooling works, and you can also purchase those coolers, and we are selling them across the globe. And on the right-hand side, this is the newest project that we have, which we will present at the Euroshop fair here in Germany next week, which is one of the leading retail shows around the world. And yeah, we are open for more collaborations with supermarkets directly, but also with manufacturers. And yeah, where do we see this technology going? So we believe that cooling is extremely important in the context of servers, data centers, IT in general, but also in the context of industry process cooling, where installation matters, where flammability matters, and the same holds true for medical cooling applications. And in the long run, where we see a lot of impact that we can bring is in the HVAC and space cooling area. So we have developed concepts to increase the cooling capacities significantly. This is not public knowledge yet, so I cannot share any details right now, but stay tuned, and in the upcoming months you will then learn more details on how we can actually increase the cooling capacity for those larger applications as well. Yeah, that's it from my side for now. So I want to leave with the note that we are also active in hydrogen liquefaction, where we bring down this technology to minus 250 degrees centigrade. So this is a research-oriented project, which we are currently doing. So we are still very much involved with the research institutes that we originate from. So always happy to share more details on the more future outward-looking projects that we have. But yeah, for the time being, I want to thank you very much for your attention, and I'm very much open for questions, and hopefully I have the good answers for you now. So I will stop sharing my screen and bring it back to Christine. Thank you very much.
Yeah, thanks also from my end. I think from our side, Timur, really interesting to see what you have planned, projects that are coming up. And also, I think for us, it's really interesting to see what is possible even without refrigerant gases. I can also see a lot of questions in the chat already. We will address them after the second presentation in the Q&A session. Yeah, as many as we can. And otherwise, you shared also your contact details. So I'm sure, yeah, we can connect you as well with people interested. Yeah, with that, we are now coming to the second pioneering company today. I'm really happy to welcome Sabine Stein again. She's CEO and founder of Pervormance International. And she also won the German Sustainability Award 2025 with the products of Pervormance. So glad to have you here, Sabine. Yeah, the floor is yours.
Thank you very much, Christine.
Just let us know, or my colleague, if you would like to share your presentation, or if we should share it, and then we can guide you through it.
Please share you.
Yeah, okay,
yeah.
Then we will share it. It's coming up in a second.
Thank you very much. So thank you, Christine and Alan, and for the invitation to this webinar. And yes, hello to everybody in the room. And so I want to start with my presentation, so we have afterwards enough time for your questions. So we are a company in south of Germany, and we started in 2010 with our technology and our products for cooling people in the first step. So heat is one of the biggest and fastest growing challenges of our time, and for health, for productivity and sustainability. Today I will show you what heat stress is such a serious issue and why classic air conditioning is not the right answer in many situations, and how active cooling textiles offer an effective climate-friendly alternative. We focus on people, not on rooms. So heat stress affects far more than comfort. It reduces concentration, performance in reaction time, increases accident risks, and leads to fatigue and exhaustion. In several cases, heat can cause heat cramps. So you see collapse, heat stroke, and even life-threatening situations. So lots of people suffer from heat due to their illness, or have even more some symptoms. Whether at work, in sports, in medical conditions, or in our life. Heat is really a health risk and not just a discomfort. So slide 3, please. The next one. The problem with air conditioning, Timur said before and shows you already, is that our common response to heat is creates new problems. So today, 8% of global electricity is used for air conditioning. The systems emit around 1 gigaton of CO2 per year, and refrigerants are harmful to climate and ecology. Numbers are rising, and the biggest inefficiency, it does not work outdoors. And we cool entire rooms, although we only want to cool the people inside. Air conditioning doesn't scale sustainable in a warming world. Next, please. So our approach is different. We transform heat climate friendly into health, performance, and well-being. Instead of cooling buildings, we cool human body directly, exactly where it matters. And we can also cool outdoors. Next. And what with which technology do we this? The heart of eCoolline is our patented three-dimensional system technology, developed and produced in Germany by ourselves. So at the 3D net of smart fibers creates a powerful evaporation cooling effect up to 660 watts directly on the body. We have a big surface to cool, to have cooling effectiveness. This active cooling without electricity, without chemicals, without compressors, only with water and air. Next. So how it works. The system works like a bionic hybrid system. Water is stored inside a textile structure and evaporates in a controlled way. This removes heat from the body continuously and naturally. Even in very high humidity, cooling can be boosted for short periods using ice packs or pre-freezer preparation. It's a hybrid technology. The cooling effect has been scientifically tested and confirmed in all dimensions, in medicine, in heat at work, and so on, in sports, whatever. The next slide, please. So compared to air conditioning systems, we have with the eCoolline saves up to 97% CO2. It uses 100% water, only air, no energy source, and no emissions during using. This makes personal cooling scalable, affordable, and climate friendly. Next slide, please. This is our product portfolio, which shows with which products you can cool the body, or your body, or the employee's body. So we have many more different kinds of cooling from head to toe, and you can use it also inside, but the most important using is outdoors, because you have in outdoor situations no chance to have a cooling system with, like air conditioning or something else. Okay, next one. So we are with our products in industry, construction and crafts. Heat stress leads to accidents, errors, and lost productivity. IR camera shows you that we reduce with eCoolline products the thermal load on the body, even under protective clothing. Workers stay safer, more focused, and more productivity, with more productivity. Next slide, please. Cooling is not only about performance for workers or in sports. It can be a medical support. So we have also medical products in our range. And eCoolline is used by people with cardiac conditions, COPD, multiple sclerosis, Parkinson's, migraines, and more. Cooling reduces stress in the cardiovascular systems and improves quality of life. Next, please. Sports, as I said, and here is the performance, the goal. So in sport, it limits performance long before musicals do. Active cooling helps athletes maintain concentration, endurance, and recovery, as shown by thermal imaging. National teams and athletes use our products in range. Yes. So for daily life, for all people in our world, is heat stress also affects, and by driving, by commuting, or in leisure, or going walking. So cooling textiles offers immediate relief, especially for vulnerable groups like elderly people. Next slide, please. So the newest products that we have are for home. Cooling blankets and heat emergency kits support people during heat waves, especially when air conditioning is not available or affordable. Also, cooling sliders with our technology has curtains can cool rooms without emissions, like air conditioning. Next slide, please. So Ecoline cools 100% climate neutral because we need no fossil fuels or energy source. Sustainable production with the technology made in Germany, recycled products, upcycling of fibers, no energy consumption during use. This is cooling aligned with global climate goals. Therefore, we won the German Sustainable Award in 2025 for our products. And that last slide. So heat will increase, but emissions don't have to. Cooling people instead of rooms is one of the smartest and fastest ways to protect health, performance, and the climate at the same time. Active cooling textiles are not a niche, they are part of the future of cooling. Thank you.
Thank you very much, Sabine. Really interesting to see what you in Pervormance International are working on. And I think in one way or another, there are always synergies. Also what Timur, you said with our work, and I'm sure also with other institution, companies or partners that are present today as well. So yeah, I'm happy where this will lead us. And I see, as I said before, more questions coming up in the chat. I also saw that you, Timur, already started to answer. That's great. Thank you. I will take up one question that was not answered yet for you, Timur, from Marlin. She's asking how high is the energy needs for magnetizing and demagnetizing the materials compared to refrigerant systems? Maybe you would like to take that one, please.
So we are using permanent magnets, so that basically says it all already. So they are permanently magnetized, and we change the location of those magnets. And for that, we are using a motor. So we have basically an electrical motor with efficiencies of around 80 to 90%. And this results overall in a comparison to gas compression right now, where we use around 15 to 20% less energy than a propane system. Always in the, let's say, with the disclaimer that we look at commercial refrigeration units with a temperature span of 25 Kelvin. So always when it comes to a direct comparison, it's very difficult to do. So we try to do comparisons on a full system level. So all the questions regarding COP, it's also a difficult to answer question, because the question is always, what do you compare it to? And on a full system, the COP is around 2, but again, it highly depends. I hope this is sufficient.
Yes, thank you. I have another one for you, Timur, and then we can go over to you, Sabine. What is the typical temperature range where we can apply the technology, both internal and external temperature range?
So let me break it down in 3 steps. The first step would be, where do you see or observe those magnetic caloric effects? And this is a very wide range. So you see magnetic caloric materials with this effect at absolute zero. So there are systems for quantum computers, not us, other companies. They use this technology for quantum computers to go to absolute zero, and all the way up to 150, 160 degrees centigrade. That's the first step. Then the second step is, what's your system design? And we use a water-based fluid, so we are bound to the limits of water in our current system design, which means for us that we go down to minus 10 degrees centigrade and up to plus 55. It's not the limit of water, but this is our limit. And then what the third step is, what do we have today? And today we go from 30 degrees centigrade down to 0, which is optimized for the application of supermarkets, where you have normally temperature controlled environments, and we focus on plug-in units right now. So we start with 0 to 30. We can extend easily from -10 to +55, and theoretically it can go way beyond that.
Mm-hmm. Okay, thank you. I think the other one that I picked is also for you, Timur. Do you plan to use your IP or patents to scale with partners outside of Europe?
So yes, our vision is to shift the cooling industry. So in order to do that, we are interested in a fast adoption of this technology. So we start out obviously here in Germany, in German-speaking DACH region, but we are looking for partners globally to co-develop, but also to accelerate the market adoption of the technology. And therefore, I'm very much interested in conversations around this. And our business model is to externalize the production of the units. So out licensing basically how to build it, and we remain as a supplier of the magnetocaloric material which we are producing in-house.
Mm-hmm. Okay, perfect. Thank you. I also see one hand is raised. So Viyaja Kumar, I hope I pronounced the name right. Feel free to unmute yourself and turn your camera on if you want to, and you can ask your question. Yeah.
Can you hear me?
Yes, it's working. Perfect.
Yeah. First of all, thanks to Timur for the excellent presentation, and followed by Sabine. A lot of questions to Timur, but I restrict my question to Sabine as only one question. Good you made that we don't cool the room, we cool the people. I really appreciate that sentence. But my question for that is, if we cool a portion of the body, what is the effect of the overall health of the person? For example, a person wearing a vest or a shirt for longer time in the room temperature is a little higher. What
You can
is
also
the
wear
effect of
the
long run if you use the repeatedly that? Can you follow?
Can you
Would
repeat,
you able to understand
please?
my question? My question is, in the room, it's higher temperature. If a
Yes.
person is wearing the cooling textile like a shirt or a
Yes.
vest, whatever maybe, if you use a longer time for many days, maybe about a month or so during the summer, is it any effect on the overall health of the person? Because we are cooling a portion of the body, not entire system, right?
Yes. It's like adaptation. If you cool your body in the whole day in summer and each and every day, so your body adapt the cooling effect, and you have to wear each day because the temperature is outside the high as it is. So we can so you can protect from the high temperature, and you can stabilize your core temperature with our cooling textiles directly on your body.
Is it been adopted for any like a safety, what you call armors? For example, in the defense, they use the armors with a lot of heat generates. Is these textiles been, certified for using such a bulletproofing and such cases, special cases?
Which kind of special
like
gases?
The bulletproof jackets, for example, that's very thick and required highly specialized textiles.
There we have to we developed already a special system for under bulletproof jackets. It's not in the normal store range. It's a special kind of development, and we developed with the customer then each types, because all bulletproof jackets are different, not always the same. Yes.
Yeah, I'm just looking for that particular spec. If you're able to give some information, please email to me. Thanks to Gabriel, because of her, I joined in this team because of her communication. Thanks to her.
Okay. Thank you.
Thank you.
That's all. See you. Bye.
Thank you for the question. Sabine, I have one more question to you. Are the cooling textiles and other applications already exported?
Yes, we exported in different countries already in the last years.
Yeah.
Also to for example, Japan, Australia, South of Africa, India, America, Brazil. Yes.
Mm-hmm. And another question, is the cooling textile equally efficient in all types of climates in terms of weather and so on?
Yes, one type of climate that doesn't work because we have the technology of with water, the evaporative of water, and if you have 90 or 100% humidity, then it doesn't work. So then you have to, or you can store the products before you use in the refrigerate, and you cool or make a kind of pre-cooling for the products, and then you can use it like a hybrid system.
Mm-hmm. Okay, thank you. I will just have a quick look in the chat. I see some answers already, or many answers from you, Timur, already. Thanks for helping. I see one question that I think we haven't answered yet from Petter Nexor. What about cost of the materials used? Further, how is the efficiency on system level, also considering getting the heat and cold out of the application?
So we use as a magnetocaloric material an iron-based alloy, which contains 80% iron, roughly 8% lanthanum, which is a free rare earth. So it's abundant, it's cheap. So we can bring down the costs now significantly with new production methods on how to produce the magnetocaloric material. And this is part of our IP. So we can significantly lower now the costs compared to material systems before us. Total costs of ownership can be reduced by lower maintenance costs and a higher uptime. So gas compressors, as we have them today, they're very cost effective, and we see that there's a barrier of around 300 euros per kilowatt that we need to break. But we already see benefits today in certain contexts where maintenance is quite costly, and the need for maintenance personnel can be tremendous.
Okay, perfect. Thank you. I see one coming up for you, Sabine. Any problems with evaporating concerning to bacteria, mold, etc.? You are on mute. Just yeah, no worries.
Sorry. Our fabrics are with antibacterials. What does it mean? Ausrüstung?
Equipment.
And so we have no problems because you have always hang up the products on a or store it on a like a bügel. So always in air conditioning, so you have no problems. But afterwards, also in sports or something else, or if you have worked in your T-shirt, then you have to wash it. And our products are washable in normal washing machines or industrial washing, so that's no problem that it can be cleaned.
Yeah, perfect. I see another one that was just coming up for you, Sabine. What is the cooling textile used for migraine patients? I think I saw it in your slides, but you can just,
Yes, for the migraine patients, they can cool the head or the neck. So we have a very kind feeling, and the pain are more or less than normal for the migraine patients. And yes, they have less problems about it.
Great. I think time is running up a bit, but I think we shared, or you shared, all your contact details, and we will, yeah, as you know, record the sessions, and also, if you are okay with that, Sabine and Timur, we can share your presentations as well, and then yeah, people can just get through it or go through it afterwards and get in contact with you if
Yes.
if there's something that we haven't answered yet. I see Ellen's hand. Yeah, please.
I saw there were two more questions coming up, Christine. Maybe
Okay.
we
Yeah.
cover them also, one for Timur
Yeah.
and one for Sabine.
Yeah, that came in the last minute, yes. But we, of course, good that you mentioned this. For Timur, I think, is this magnetic technology applicable for production of all kinds of air conditioners?
So I might not know all kinds of air conditioners, but what I can say is the machine that we can build is operating between -10 and +55 degrees centigrade. So I would assume that this is it's a wide area where air conditioners are normally used. And the cooling capacities that we target can go up to 500 kilowatts. So we cannot build, obviously, billions of air conditioning systems. So we rely on partners to make this technology widely available. But the theoretical possibility definitely is there, and I'm happy to sort out any potential collaborations.
Perfect, thank you. And the other one that I saw, are there financing or incentive programs planned to support adoption? I think for Sabine maybe, but it, yeah, could be applicable to both of you, I think.
So not sure if I got the question correctly. So right now we don't rely on any external funding schemes.
Yeah.
We obviously have governmental grants to finance the developments and research activities, but there are no technology specific beneficial funding schemes outside the normal schemes that you normally have when it comes to energy efficiency improvements inside of corporates or production sites. But for our technology, this has not yet been picked up by regulators or financial institutions.
And for you, Sabine, are there any financing or funds or incentives?
No, the only we know are the assurances for works. They give I think a little bit to finance the workers' heat protection of it, but no, we don't know. We don't know anything of this.
Yeah. There was one last coming up now, but I think after that we have to stop, about the cost of appliances using magnetic technology.
So we are new technology. Gas compression has been around for 150 years. So of course, right from the start, we cannot be lower in cost than the current technology. But I'm coming back to the point of total costs of ownership. When it comes to maintenance-heavy applications, there are cost benefits to our technology already today, because we eliminate the need for specialized trained people, and we can lower the energy consumption of systems. So it's a total cost of ownership perspective, and that's where we focus right now, also where operators and applications are scrutinized by TCO rather than only CapEx.
Yeah, okay. Yeah, I'm looking at the time. We have 4 minutes left. I would really say a big, big thank you to both of you. It was really great to see your presentations and that you shared your technologies with us. And I think for all of the people that were joining here today, yeah, it's really, really nice to see these upscaling potentials of the technologies. And I think it's always good to use these kind of networks to get in contact with each other and see where the synergies might lead us in the future. Thank you to all of you for your participation today. It was a really active chat, a lot of questions. That's really nice to see. We always have questions, but this is really a lot of questions, so I'm really happy about that. Thank you. I hope you have gained valuable insights. Of course, we will have more webinars coming up throughout this year. We will keep you posted via our website and our LinkedIn that you can see here on the slide. Yeah, we would of course be happy to seeing you again soon. Yeah, and with that, in the name of Proklima and the speakers, I would like to thank you for your participation. Take care, goodbye, and see you soon. Thanks a lot.
Thank you. Bye-bye.
Thank you both.
You.
Thank you also. Bye-bye.
Bye.